The for-each loop in PHP is a powerful and extremely convenient structure designed specifically for working with arrays. Instead of manually tracking indexes like we do in a traditional for loop, the for-each loop automatically handles the internal pointer movement over each array element. This means PHP quietly walks through the array in the background, giving you each value one at a time without requiring any extra work. In the example shown, we start with an array named vehicles, which contains 4 items: car, bike, bus, and bicycle. When the for-each loop begins, PHP internally moves an invisible pointer to the first item of the array and assigns its value to the temporary variable value. At this moment, value holds the word car, and the echo statement prints it on the screen. Once the current cycle finishes, PHP automatically shifts the pointer to the next element. On the second iteration, value becomes bike, followed by bus, and finally bicycle. This hidden pointer movement continues until all elements have been processed, and then the loop naturally ends. To visualize what's happening internally, imagine the array items arranged in a straight line inside memory. PHP has a built-in for-each engine that reads the array layer element by element. As each element is reached, the loop layer receives the value and temporarily assigns it to the variable value so the program can use or display it. You don't have to manage the pointer, the index numbers, or the stopping condition. PHP takes care of all of that automatically. The for-each loop is therefore cleaner, safer, and easier to understand, especially for beginners who want to work with arrays without worrying about the technical complexity behind indexing. The output panel in the graphic confirms the result clearly. Each item from the array is printed on a new line: car, bike, bus, and bicycle. This demonstrates how seamlessly for-each iterates through the collection. At a conceptual level, the process flow begins with the array, then passes through the for-each engine, which extracts each element one by one. That extracted value is stored in $value, and finally, the output renderer displays it on the screen. In summary, the for-each loop in PHP is an elegant tool that simplifies array iteration by managing memory, indexing, and pointer movement internally. It provides a clean and intuitive way to process each item, making it ideal for readable, error-free, beginner-friendly code.
In this part, we explore how the for-each loop works when dealing with associative arrays in PHP, arrays where each item has a specific key paired with a value. Unlike normal indexed arrays that use numeric indexes starting from 0, associative arrays use custom labels, such as names or words, to identify each value. The double arrow operator, written as equals greater than, is what connects each key with its value. The key is placed on the left, and the value is placed on the right. For example, in the array flower equals array rose equals 10, lily equals 20, lotus equals 30, the words rose, lily, and lotus act as keys, while the numbers 10, 20, and 30 are their corresponding values. When PHP runs a for-each loop that uses the format for each flower as x equals value, PHP automatically assigns the key to the variable x and the matching numeric value to the variable value. This means you get access to both pieces of information inside the loop without doing any manual indexing or mapping. During each iteration of the loop, PHP internally steps through the associative array in the order it was created. On the first cycle, x becomes rows and value equals 10. The echo statement prints rows equals 10 as output. In the second cycle, x changes to lily and value becomes 20, producing lily equals 20. Finally, in the third cycle, x becomes lotus and value equals 30, displaying lotus equals 30. This chain-like movement continues until all key value pairs are processed. The visual representation in the image shows this clearly. The associative array first enters the for-each engine, which separates keys and values. Keys flow into the variable x, and values flow into value, and both combine to form the final printed output. This structure is extremely useful in practical programming because it allows you to work with meaningful labels instead of numerical indexes. Whether you are managing product names with prices, usernames with IDs, or any form of labeled data, the for each loop provides a clean, readable, and highly efficient way to access both the identifier and its associated value at the same time. Overall, this approach makes associative arrays easy to process, reduces errors, and improves code clarity, especially for beginners learning how PHP stores and retrieves paired information.
In this section, we explore the purpose and internal behavior of the break statement in PHP, which is an essential control flow tool used to immediately stop the execution of a loop or a specific block of code. The break statement acts like an emergency exit. The moment a certain condition becomes true, PHP stops the loop instantly and jumps to the next line of code that appears outside the loop. This makes break extremely useful when you don't want a loop to run through all its iterations. Instead, you only want it to continue until a particular situation occurs. For example, in the displayed code where the loop runs from 1 to 10, the break statement is placed inside an if condition that checks when x becomes equal to 4. As soon as the value of x reaches 4, the break command is triggered, the loop ends immediately, and execution continues after the loop. Because of this, only the numbers 1, 2, and 3 are printed. Number 4 never gets printed since the loop is forcibly exited beforehand. The flowchart provided makes the process clearer. The loop begins with x set to 1 and checks whether the stopping condition is met. If not, PHP prints the current value of x and then increases it by 1. This cycle continues until x reaches 4. At that exact moment, the condition x equals 4 becomes true, leading the break statement to activate. The visual diagram shows a red break encountered box, representing the point where the loop stops completely. Once break is executed, PHP does not go back to the loop for any further checks or increments. It simply moves on to the next part of the program. This behavior ensures efficient control over how long a loop should run, especially when you only need to process data up to a specific threshold or until a certain condition is met. Break is not limited to loops. It is also widely used inside switch case statements, where you need to stop the execution of one case and prevent the following cases from learning unintentionally. In summary, the break statement gives you precise control over execution flow by allowing you to exit a loop early, stop when a condition becomes true, and manage switch case logic cleanly. It helps keep programs efficient, avoids unnecessary iterations, and ensures that your script responds immediately when a specific event or condition is detected.
In this section, we dive deeper into the behavior of the break statement inside PHP loops, using a practical example that begins counting from 5 and continues up to 15. The loop runs automatically from one number to the next, but inside the loop, there is an important condition that checks when the variable $n becomes equal to 9. As soon as the loop reaches the value 9, the break statement is triggered, and this instantly forces the loop to stop running. Because break causes an immediate exit, the loop does not print the number 9, nor does it continue to any values after 9, such as 10, 11, or beyond. Instead, it prints only the numbers 5, 6, 7, and 8, and then the program moves on to whatever code appears after the loop. The flow diagram makes this concept visually clear. The loop starts at 5, and each iteration echoes a number, moves forward, and checks the condition again. When $n is 5, 6, 7, and 8, the condition $n equals 9 is false, so the loop continues normally. However, once $n increments to 9, the condition becomes true, and the loop encounters the break statement. At this moment, the execution flow jumps out of the loop entirely, shown in the diagram as a bright red break symbol where the loop snaps open and ends immediately. This is a powerful way to stop unnecessary iterations and control program flow efficiently. The "how break works here" explanation reinforces the internal logic. It clarifies that the loop is originally designed to run up to 15, but break interrupts this natural progression before it reaches the maximum limit. The break statement is often placed inside if conditions because this allows you to specify exactly when and why the loop should stop. This technique is useful in many situations where you only want to search until a match is found or process items only until a certain condition becomes true. In summary, the break statement gives you full control by stopping a loop exactly when needed, preventing wasted processing time, and making your script more efficient, clean, and predictable.
we explore the continue statement, which plays an important role in controlling the flow of loops in PHP. While the break statement completely exits a loop, the continue statement works differently. It only skips the current iteration and immediately jumps to the next cycle of the loop. This means that any code written after continue inside the loop block will be ignored for that particular iteration. Once continue activates, PHP does not execute the echo statement or any additional logic inside the loop for that moment. Instead, it moves directly to the increment step and proceeds with the next value. This makes continue extremely useful when you want to temporarily skip over specific values or filter out certain conditions without stopping the entire loop. In the provided code example, the loop runs from n equals 0 up to n is less than 10. Inside the loop, an if condition checks whether n is equal to 4. The moment n becomes 4, the continue statement triggers. As a result, PHP jumps over the echo statement for that iteration, and number is 4 is never printed. The output visualization clearly shows this. The loop prints numbers 0, 1, 2, 3, then skips printing 4 and continues with 5, 6, 7, 8, and 9. This demonstrates how continue allows the loop to keep running normally while skipping only selected iterations based on conditions that you specify. The flowchart provides a clear picture of how this works internally. Each cycle begins by checking if n is less than 10. If true, the loop checks whether n equals 4. When the value is not 4, PHP executes the echo statement and prints the number. But when n equals 4, the yes path guides the process toward the continue statement, causing the printing step to be bypassed. After skipping the print statement, the loop moves to increment n and continues forward. The loop ends naturally only when the condition n is less than 10 becomes false. This mechanism allows fine-grained control without interrupting the overall loop structure. The key takeaways emphasize the purpose clearly. Continue is designed to skip the remaining code in the current loop iteration, making it ideal for filtering out unwanted values. Unlike break, it does not stop the loop entirely. It only bypasses specific conditions while allowing the loop to keep running until its ending criteria are met. This makes continue a valuable tool for building cleaner, more controlled loop logic in situations where selective skipping is required.
In this part of the PHP Loop Control series, we take a deeper look at how the continue statement works inside loops and how it affects program flow. Unlike the break statement, which completely stops and exits the loop, the continue statement behaves more selectively. It skips only the current iteration of the loop and then immediately jumps to the next cycle. This means that any code appearing after the continue keyword inside the loop body is ignored only for that specific iteration, while the loop itself keeps running normally until its end condition is reached. In the given code snippet, the loop starts at n equals 0 and continues up to n less than 10. During every iteration, the program checks whether n is equal to 4. When n becomes 4, the condition is true, so the continue statement activates. At this exact moment, PHP skips the echo line that would normally print the number. As a result, the number is I4 is never displayed. Instead, PHP moves directly to the increment step and continues with n equals 5. Because of this, the output displays numbers 0 through 3, skips 4, and continues from 5 to 9. The output visualization clearly highlights the missing 4, showing how continue skips only a single iteration rather than stopping the entire loop. The flow diagram in the infographic breaks down the logic step by step. First, the loop checks whether n is less than 10. If true, PHP then checks whether n equals 4. If n is not 4, the number is printed normally, but if n equals 4, the continue block is triggered, sending control directly to the increment stage, without running the print statement. The loop then repeats from the top, checking the condition again. This process continues until n reaches 10, at which point the loop ends naturally. This flow illustrates why continue is useful for filtering unwanted values, skipping specific conditions, or cleaning data during iteration without interrupting the full execution of the loop. The key takeaways summarize the concept clearly. The continue statement skips the current iteration, ignores the remaining lines inside the loop body, and then allows the loop to proceed normally. It does not terminate the loop like break. Instead, it ensures that only selected values or conditions are bypassed. This makes continue a flexible and powerful tool when you need fine-grained control over how each loop cycle behaves, especially in scenarios involving data validation, condition-based filtering, or skipping invalid entries.
Before arrays existed, managing multiple pieces of related data in PHP was extremely difficult because developers had to rely on creating many individual variables. For example, storing information about several car names required variables like $car12, $car13, $car14, and $car22. As the number of items grows from 10 to 100 or even 300, keeping track of all these separate variables becomes chaotic and nearly impossible to manage. Such an approach leads to messy code, repeated variable names, and a structure that is difficult to search, loop through, or modify. This kind of scattered data makes a program harder to maintain, increases errors, and slows down development. Arrays solve this entire problem by allowing you to store multiple values inside a single variable. Think of an array as a container or a digital folder that holds many items together in an organized way. Instead of creating dozens of separate variables, you simply create one array, such as cars, and place all the car names inside it. This creates a clean, manageable, and scalable structure that is easy to work with. Arrays make it simple to store lists of data such as names, items, car models, products, or any set of related values. They can hold just a few items or hundreds of values without requiring new variable names. Because arrays work perfectly with loops like for and for each, they allow you to process, search, or display large sets of information efficiently and with minimal code. The real-life analogy in the infographic explains this in an easy way. Without arrays, handling many variables feels like juggling dozens of loose sheets of paper that are messy and unmanageable. But with arrays, it becomes like storing all those sheets in a single folder. Everything is organized, easy to access, and simple to update. The basic syntax for creating an array in PHP is shown in the example. $names equals array Ali, Sarah, John, Aisha, and David. This single variable now holds 5 different names, demonstrating the power of arrays. No duplicate variable creation, no confusion, and no complexity. Just one container with multiple values. Arrays offer several key benefits. They are compact, meaning many values are stored in one place. Loop-friendly, allowing you to easily work with loops. Dynamic, meaning they can store a few items or hundreds of values. Clean, helping eliminate repeated variable declarations, and organized, keeping data grouped logically. Ultimately, arrays solve the problem of storing and managing large sets of data efficiently. They make your code cleaner, more scalable, and far easier to maintain, serving as a foundation for many PHP operations that work with structured information.
This visual guide provides a complete understanding of arrays in PHP by breaking the topic into clear sections that explain why arrays are needed, what they are, the different types of arrays, and how they help us write cleaner and more efficient code. The first section highlights the core problem. Without arrays, storing large amounts of related data requires creating hundreds of individual variables, such as name1, name2, name3, and so on. This becomes impractical, hard to manage, and impossible to maintain or loop through efficiently. The solution is the array, a special structure that allows you to store unlimited values inside a single variable, keeping your code organized, scalable, and easy to update. In the second section, we learn what an array actually is. An array is a data structure that stores multiple values under one variable name. These values are accessed using an index or a key, making it flexible for various use cases. Arrays can be created using the array function or the modern bracket syntax. For example, $numbers equals array of 10, 20, 30, 40, stores 4 numeric values in one container. This ability to hold multiple items in a single variable makes arrays essential for every PHP program. The third section highlights the benefits of arrays. Arrays make your code cleaner by grouping related data together. They allow you to store many values in a compact form, making your program easier to manage and update. Arrays work perfectly with loops, which means you can effortlessly display, search, or modify large collections of data. They are scalable, capable of holding a few values or even thousands, and they support indexed access, giving you precise control over the data stored in them. A real-life analogy in the next section makes the concept even clearer. Without arrays, managing many pieces of data feels like holding a stack of loose papers. Messy, confusing, and hard to work with. With arrays, it becomes like storing those papers nicely inside a folder. Everything is organized, easy to find, and simple to update. This analogy represents exactly what arrays do for your code: turn chaos into order. The guide then explores the 3 main types of arrays in PHP. Numerical arrays, or indexed arrays, store values in a linear list using numeric indexes starting from 0. An example is apple, banana, grapes, which is perfect for simple lists. Associative arrays use strings as keys, letting you store data in key value pairs such as user information. Name equals Ali, age equals 25, city equals Lahore. This type is more meaningful and readable. The third type, multidimensional arrays, stores arrays inside other arrays, making them ideal for handling tables, datasets, or complex structures, like student records, where each entry includes both a name and age. Section 6 shows how to access elements using the appropriate syntax: $array 0 for indexed arrays, $array name for associative arrays, $array 1 0 for multidimensional arrays. This gives you full control over retrieving and displaying values from any type of array. Finally, the summary box emphasizes the importance of arrays in PHP. They allow you to organize, store, and access unlimited values using just one variable, making your programs clean, efficient, and powerful. Arrays are the backbone of effective data management in PHP, and understanding them is a major step toward becoming a confident PHP developer.
This infographic explains numerical arrays in PHP, also called indexed arrays, by breaking the topic into clear and easy-to-follow sections. A numerical array is a type of array in which each value is stored using a numbered index. These indexes always begin at 0, unless manually changed. This means the first value is at index 0, the second at index 1, and so on. Numerical arrays can store numbers, strings, or even mixed types all in one list, making them ideal for situations where you simply want to store and access multiple values in order. The visual representation helps you clearly understand how numerical arrays store values. For example, if you have the array 21, 22, 23, 24, 25, 26, the index 0 holds the value 21, index 1 holds 22, index 2 holds 23, and this continues in sequence. PHP automatically assigns these index numbers, making your work simpler and more organized. You can then use these indexes to retrieve or modify any value in the array. The code snippet provided in Section 3 demonstrates how numerical arrays work in real PHP code. The array num equals array 21, 22, 23, 24, 25, 26 creates a list of numbers. The for each loop then reads each value automatically and prints it. You don't need to refer to indexes manually here because for each handles that for you. The output will show value is 21, value is 22, value is 23, and so on. After displaying the original values, the code shows how you can modify specific elements by referring to their indexes. For example, num0 equals 1 replaces the first value with the string 1, and num1 equals 2 updates the second value. This flexibility allows you to update any part of the array at any time. The step-by-step flow in section 4 explains the process clearly. First, you create the numerical array. Second, you loop through the values using for each to display them. Third, you modify specific values using index numbers. The key concepts in section 5 reinforce the most important points. Indexes always start at 0. For each automatically reads values without needing manual indexing, and you can directly change values by referencing their index. The output preview in section 6 shows how the data appears before updates, while the visual summary in section 7 compares the array before and after modification. Initially, index 0 contains 21, and index 1 contains 22. After the updates, index 0 changes to 1, and index 1 becomes 2. This clearly illustrates how numerical arrays make it easy to store, access, and update multiple values in a clean and efficient way.
Associative arrays in PHP offer a powerful way to store and access data by using string-based keys instead of numeric indexes. While numerical arrays use index numbers like 0, 1, and 2, associative arrays allow you to assign a meaningful word or label as the index, such as John, Peter, or Mark. This creates a logical and human-readable connection between the key and its value. The key acts like a descriptive label, and the value represents the data associated with that label. This structure helps you quickly understand what each value represents without having to guess based on numeric indexing. In the real example shown, the associative array $age stores ages for different people. Each name is used as a key. John equals 20, Peter equals 25, and Mark equals 30. When you write echo $age John, PHP finds the key John inside the array and returns the value 20. This shows how associative arrays allow you to access information directly using meaningful names, rather than relying on the position of a value in a list. This process is made possible by the equals, greater than, or the double arrow operator, which maps each key to its corresponding value. The left side of the arrow defines the key, while the right side defines the value, making the relationship clear and easy to read. Associative arrays are especially useful because they greatly improve clarity and readability in your code. For example, accessing $age John is far easier to understand than using $age 0, where you have to remember what index 0 represents. This simple improvement helps reduce errors and makes your code more understandable for both you and other developers who may read it later. Associative arrays also allow direct access using meaningful names, which is extremely helpful when working with large datasets. Another major advantage of associative arrays is that they are perfect for storing labeled or structured data. For instance, you can store employee names mapped to their salaries, product IDs mapped to prices, or student names mapped to grades. This makes data more organized, allowing it to be accessed, displayed, or modified in a clear and efficient manner. Overall, associative arrays give developers a flexible, readable, and structured way to store key-value pairs, making them essential in almost every real-world PHP application.
This is a clear side-by-side understanding of numerical arrays and associative arrays in PHP, showing how they differ and when each one should be used. On the left, the numerical array is shown with indexes that are always numbers, starting from 0. This means the first item is stored at index 0, the second at index 1, and so on. Numerical arrays are ideal for ordered lists, where the position of each item is more important than its label. For example, if you store values like 1, 2, and 23, PHP assigns them automatic indexes 0, 1, and 2. You can access them by writing num0, num1, and num2. This type of array is perfect for sequences, lists, and simple collections of data where you just need to store items in order. On the right side, the infographic shows associative arrays, which replace numeric indexes with string-based keys. Instead of using numbers to store and access values, we use meaningful labels, such as John, Ollie, or Sarah. These labels act as keys, and they point to their respective values, such as ages, 20, 25, and 30. To access a specific value, we simply reference its key, like age_John.
Associative arrays create a direct connection between a descriptive key and the value attached to it, making the data much easier to understand, especially in real-world cases such as storing employee salaries, product names with prices, or customer profiles. In the comparison section, the differences are summarized visually. Numerical arrays use numeric indexes, store ordered data, and are best for sequences or simple lists. Associative arrays use string keys, rely on key value mapping, and are best suited for labeled data where the key has meaning and helps identify what the value represents. While numerical arrays are excellent for looping through large sets of data in a specific order, associative arrays are more flexible and make your code more readable by letting you use human-friendly keys. Overall, the infographic shows that both types of arrays serve different purposes, but are equally essential in PHP. Numerical arrays keep data simple and ordered, while associative arrays allow for labeled and more meaningful data organization. Understanding both structures helps developers write cleaner, more efficient, and more logical programs, whether working with simple lists or complex datasets.